Okay. The first pink sheet review that we'll talk about is the Pythagorean theorem. And the Pythagorean theorem, you have to have a right triangle, which means that one of the angles right here has to be 90 degrees. Otherwise, it won't work. Now, when you're talking about the right triangle, you have a leg here, and this is called a hypotenuse. Now, traditionally, when we talk about Pythagorean theorems, we talk about the right triangle that'll end up looking like this, and A and B are your legs, and your legs make the 90-degree angle, and C makes the hypotenuse. And the theorem itself is A squared plus B squared is equal to C squared. And we can transform this in a lot of different ways. If you don't know a leg but you know two other parts, you can subtract like B squared from both sides and get A squared is equal to C squared minus B squared, or however you need to do this. Then you just take the square root as needed. So you take the square root of A squared, which is equal to A, which would be equal to the square root of C squared minus B squared. Or if it's just the traditional one, and you say, all right, well, I just need C squared. I need C, so C is equal to the square root of A squared plus B squared. Now, a simple example of this would be you have a right triangle. Not drawn to scale, of course. Here's your example. Say that's 5 and that's 12, and I need to know what C is. This would be my A, this would be my B, and there's my C. So the Pythagorean theorem says A squared plus B squared is equal to C squared. My A, I'll just take as 5, so that's 5 squared plus 12 squared is equal to C squared. 5 squared is 25, plus 12 squared, which is 144, which is C squared. So I get 169, which is C squared. I don't want C squared. That's not the answer that I want. I want C. I want C by itself, because here I don't see the squared there. So I'm going to take the square root of C squared, which is equal to C, which is the square root of 169, which is a perfect square. That's why I chose it. C is equal to 13. You could have put this in your calculator. You could have taken the calculator and said to yourself, all right, well, at this point, there's two things you could have done. One, you could have said, I just want to take the square root of 5 squared plus 12 squared, and you would have got the answer 13. You could have gone from this point right here, and you could have said, I want a numeric solve. I think this will work. Now we go to algebra. Down here, we want to go to numeric solve and say, all right, well, I don't want C squared. I'll just change it to X, and I'll say 5 squared plus 12 squared is equal to X squared. Then I want to go comma X, because that'll solve your equation, and you'll get 13. It'll give you the positive value for X. So you can end solve it there. So you can do a lot of different things, and if you had gotten to the point where you just wanted to take the square root of 169, there you go. There it is, 13, and you're all set. So the Pythagorean theorem is going to be there. There's going to be some problems with it, guaranteed. Now, if we go to our master sheet, and I'm going to create one right now. And up at the top, I'm going to call it the master the master pink sheet. And if you think I wrote that big, I did not. I wrote it extremely small. I'm going to start in the upper corner. And I'm going to not even do the whole thing. Pythagorean theorem. I'm going to draw the shape just right here. That's my A, that's my B, that's my C, and say A squared plus B squared is equal to C squared. And you're responsible for knowing where A is, where B is, where C is, and I'm going to put a little box around that so we can go to the next one. I'm going to put another one here. Pythagorean triples. And that would be like 3, 4, 5. Or, like we just found out, 5, 12, 13, where all the numbers are integers. So those might pop up as well. So you'll have at least a couple different ones on your master pink sheet. So hopefully good luck with that. That's your first part for your master pink sheet.